This is the EdExcel AS Level Maths Paper 1 covering the pure mathematics content, and it's from the 2022 series. Question number 1, we have to find the integral of 8x to the power of 3 subtract 3 over 2 times the square root of x plus 5 with respect to x, giving your answer in simplest form. Well, we can rewrite this integral as the integral of 8x to the power of 3 subtract 3 over 2 multiplied by x to the power of negative 1/2 plus 5 with respect to x. What you will find here is negative 3 over 2 times x to the negative 1/2 is the same as negative 3 over 2 times the square root of x. We have rewritten this third in indices form. And now integrating becomes quite easy. To integrate the result over here, we add 1 to the power and then divide by the new power. And so, if I add 1 to the power, we have x to the power of 3 plus 1, which is 4. And then if we divide by the new power, 8 divided by 4, that's 2. So integrating 8x cubed, we end up with 2x to the 4. Similarly, if we were to integrate negative 3 over 2 x to the negative 1/2, well, we add 1 to the power, negative 1/2 plus 1, that is x to the half, and then we divide by the new power, negative 3 over 2 divided by 1/2, that's negative 3. And then if we integrate 5, 5 is the same as 5x to the power of 0. And so, if we were to integrate 5, we end up with 5x. And then we add on a constant of integration, plus c. So integrating 8x cubed subtract 3 over 2 times the square root of x plus 5, we end up with 2x to the 4 subtract 3x to the half plus 5x plus c. Question number 2. F of x is equal to 2x cubed plus 5x squared plus 2x plus 15. For part A, we have to use the factor theorem to show that x plus 3 is a factor of f of x. For part A of the question, if we were to show that x plus 3 is a factor of f of x, well, what we need to do to begin with is set x plus 3 equal to 0. And if we do that, we can see then x is equal to negative 3. And so what we need to do at this point is substitute in x equals negative 3 into f of x. And so f of negative 3, we have 2 multiplied by negative 3 cubed plus 5 multiplied by negative 3 squared plus 2 multiplied by negative 3 plus 15. And if we work this out, well, if I have negative 3, and then if I cube this result and multiply it by 2, and then add on 5 times negative 3 squared, and then add on 2 times negative 3, and then add on 15, it turns out we get 0. And so what we can see here then is f of negative 3 is equal to 0. And therefore x plus 3 is a factor of f of x, and that's because f of negative 3 is equal to 0. For part B of the question, we have to find the constants a, b and c such that f of x is equal to x plus 3 multiplied by ax squared plus bx plus c. So, for part B of the question, we have x plus 3 being multiplied by ax squared plus bx plus c, and the result of this is f of x, which we know to be 2x cubed plus 5x squared plus 2x plus 15. And what we need to do is determine the values of a, b and c. And we can do this through a variety of methods. One way is to compare coefficients. And if we compare coefficients of the x cubed terms, well, what multiplies to give an x cubed term? We have the x multiplied by the ax squared. That gives the 2x cubed. And so in terms of the coefficients of x cubed, a is equal to 2. If we now take a look at the x squared terms, what multiplies to give an x squared term? Well, we have the 3 being multiplied by the ax squared, and we also have the x being multiplied by the bx, and that would give the 5x squared. So we have 3a plus b equals 5. We know what a is, that's 2. So we have 3 multiplied by 2 plus b equals 5. We can conclude from this b equals -1. And if we compare the number terms, well, comparing the number terms, on the left we have 3 of them being multiplied by c, and on the right we've got 15 of them. And so we have 3c equals 15, in which case we can conclude c is equal to 5. We now know the values of a, b and c, and therefore we can conclude f of x is equal to x plus 3 multiplied by 2 x squared subtract x plus 5. here is f of x. For part C of the question, we have to show that f of x equals 0 has only one real root. For part C of the question, we are solving f of x equal to 0, and so we have x plus 3 multiplied by 2x squared subtract x plus 5 equals 0. Now, what we can see from here then is if x plus 3 is equal to 0, that would imply that x is equal to negative 3. This is a solution. And now we need to check if 2x squared subtract x plus 5 equals 0 has any solutions. Well, if we were to use the discriminant, well, using the discriminant, we've got b squared subtract 4ac equaling negative 1 squared subtract 4 times by 2 times by 5. And so, if we work out what this is, it turns out the discriminant b squared subtract 4ac is equal to negative 39. And this result here is less than 0. And so what we can conclude from here then is 2x squared subtract x plus 5 equals 0. This quadratic equation has no real solutions, and so therefore x equaling negative 3 is the only solution to f of x equaling 0. For part D of the question, we have to write down the real root of the equation f of x subtract 5 equals 0. Well, for part D, if we consider going from f of x to f of x subtract 5, the type of transformation this is, it's a translation by vector 5, 0. And so the way we find the solution to f of x minus 5 equals 0 well, we know for the solution of f of x equals 0, we have negative 3 as our only real solution. And then what we do with this negative 3 is we add on to it 5, because we are translating our x coordinates by 5 units to the right. And if I work out what this is, we get 2. And so, therefore, x equals 2 is the only real solution to f of x minus 5 equals 0. Question number 3. The triangle PQR is such that PQ is equal to 3i plus 5j and PR is equal to 13i subtract 15j. For part A we have to find QR. Well, we begin with a diagram illustrating what we know so far. We've got PQ and PR, and we need to find out QR. So for part A of the question, we've got the vector QR equaling the vector QP plus the vector PR. So the vector QP, that will equal negative 3i plus 5j, and the vector PR, that's 13i subtract 15j. And if we work out what this is equal to, negative 3i plus 13i is 10i, negative 5j subtract 15j, that's negative 20j. So the vector QR is 10i subtract 20j. So we have QR equaling 10i subtract 20j, and that's shown on the diagram. For part B of the question, hence find the magnitude of QR, giving an answer as a simplified surd. So for part B, we need to find the magnitude of QR, and if we work out the magnitude of QR, we have 10 squared plus negative 20 squared, and then this is square rooted. And if we work out what this is, we have the square root of 10 squared plus negative 20 squared. It turns out we have 10 multiplied by the square root of 5. Now for part C, the point S lies on the line segment QR, so that the ratio QS to SR is equal to 3 to 2, and we have to find the vector PS. Well, let's suppose here somewhere we have the point S. What we can do to find out what PS is first of all find out what QS is using information about this ratio. And if the ratio QS to SR is equal to 3 to 2, that means then, for part C, QS is equal to 3/5 times by QR. Now, I already know what the vector QR is, so I need to multiply this vector by 3/5. So, we have 3/5 multiplied by 10i subtract 20j. And if I work out what this is, we end up with 6i subtract 12j. And so here for QS, we have 6i subtract 12j. And what we need to do is find out what the vector PS is. So, to find out what PS is, well, we can add together PQ and QS. And so therefore, the vector PS, that's equal to the vector PQ plus the vector QS. So if I add the vector PQ, which is 3i plus 5j, to the vector QS, which is 6i subtract 12j, it turns out the vector PS is equal to 9i subtract 7j. Question number 4. Figure 1 shows a sketch of triangle ABC with AB equaling x plus 2 centimeters, BC equaling 3x plus 10 centimeters, and AC equaling 7x centimeters, and the angle BAC equaling 60 degrees, and the angle ACB equaling theta degrees. For the first part of part A, we have to show that 17x squared subtract 35x subtract 48 is equal to 0. What we can do over here is use the cosine rule. And if we were to use the cosine rule, well, what we have is two lengths and an included angle, and a side opposite that included angle, which is why we can use the cosine rule. And if we were to use the cosine rule, we have BC squared equaling AB squared plus AC squared subtract 2 times AB times AC times by the cosine of the angle BAC. So BC squared, that will equal 3x plus 10 squared, and that's equal to AB squared, so that is x plus 2 squared plus AC squared, so that is 7x squared subtract 2 multiplied by AB, which is x plus 2, multiplied by AC, which is 7x, times by the cosine of BAC, which is the same as the cosine of 60 degrees. And recognizing that the cosine of 60 degrees is 1/2, we multiply that 1/2 by this -2 to get -1. So in other words, the -2 and the cosine of 60 degrees simplifies to -1. What we end up then is 3x plus 10 all squared, which is the same as 9x squared plus 60x plus 100 equaling x plus 2 all squared, which is the same as x squared plus 4x plus 4 plus 7x all squared. So that's the same as 49x squared subtract x plus 2 times 7x. So that is the same as subtracting 7x squared and then subtracting 14x. And so if we simplify, the right hand side remains the same as 9x squared plus 60x plus 100, and on the right hand side, x squared plus 49x squared subtract 7x squared, that's 43x squared. Then we have 4x subtract 14x, so that's negative 10x, and then we have the plus 4. If I take everything over to one side, we have 43x squared subtract 9x squared, which is 34x squared. Then we have negative 10x subtract 60x, so that's negative 70x. And then we have 4 subtract 100, which is negative 96. And this is equal to 0. And then if I divide each term by 2, what we end up with is 17x squared subtract 35x subtract 48 equals 0. And that's exactly what we wanted to show. Now for the next part of the question, we have to find the value of x. Well, if I factorize this quadratic, we have 17x plus 16 being multiplied by x subtract 3, and the product of these is 0. So we can see then x is either equal to negative 16 over 17, or we have x equals 3. And so therefore, what we can conclude then is x equals 3 is the only solution, and that's because x must be greater than 0. Length must be greater than 0. Now for part B, hence find the value of theta giving an answer to 1 decimal place. Well, with x equaling 3, this length of AB will equal 3 plus 2, which is 5. This length over here will equal 3 multiplied by 3 plus 10, which is 19. And this length here is equal to 7 times by 3, which is 21 on the units, centimeters. And so if we recreate this diagram with our lengths of 5 centimeters, 19 centimeters, and 21 centimeters, to find out what theta is, we can use the cosine rule. And so using the cosine rule, we have 5 squared equals 19 squared plus 21 squared, subtract 2 times 19 times 21 times by the cosine of theta. So cos theta, that will equal 19 squared plus 21 squared, subtract 5 squared, divided by 2 times 19 times by 21, and if I work out what this is, it turns out we have 0.973, etc. And if we find out what theta is from this, we have the inverse cosine of the 0.973, etc. Theta then is equal to 13.2 degrees given to 1 decimal place. Question number 5. The mass A kilograms of algae in a small pond is modelled by the equation A equals P multiplied by Q raised to the power of T, where P and Q are constants and T is the number of weeks after the mass of algae was first recorded. Data recorded indicates that there is a linear relationship between T and log base 10 of A given by the equation log base 10 of A equals 0.03T plus 0.5. For part A, we have to use this relationship to find a complete equation for the model in the form A equals P multiplied by Q raised to the power of T, giving the value of P and the value of Q each to 4 significant figures. So, for part A, we begin with log base 10 of A equaling 0.03T plus 0.5. Now, we want A equals something. So, to get rid of this log base 10, we need to anti-log both sides, leaving us with A equals 10 raised to the power of 0.03T plus 0.5. And using the laws of indices, this will be the same as 10 to the power of 0.03T multiplied by 10 raised to the power of 0.5. And so, therefore, we have A equals 10 to the power of 0.5 multiplied by 10 to the power of 0.03 raised to the power of T. And now we need to work out these values to 4 significant figures. And if we do that, 10 to the power of 0.5, that is the same as 3.162 to 4 significant figures. And then we multiply this by 10 to the power of 0.03 to the power of T. So that is the same as 1.072 raised to the power of T. And this is given to 4 significant figures. Next, for part B, with reference to the model, we have to interpret the value of the constant P and the value of the constant Q. First of all, P, which is the 3.162, that would represent the initial mass of algae 0 weeks after the mass of algae was first recorded. And then Q, which is the 1.072, that represents the rate of growth of algae in kilograms per week. For the first part of part C, we have defined according to the model the mass of algae in the pond when t equals 8, giving your answer to the nearest 0.5 kilograms. So what we are doing for the first part of part C is finding out the corresponding value of A when t equals 8. And so here we have A equals 10 to the power of 0.5 multiplied by 10 to the power of 0.03 to the power of 8. So we have A equals 10 to the power of 0.5 multiplied by 10 to the power of 0.03 raised to the power of 8. So we end up with 5.495, etc. And so we can conclude over here A is equal to 5.5 kilograms, and that is to the nearest 0.5 kilograms. And then for the next part of part C, the number of weeks it takes for the mass of algae in the pond to reach 4 kilograms. So what we are doing here is finding out the value of t, which gives an A value of 4. And so here we have 10 to the power of 0.5 multiplied by 10 to the power of 0.03 to the power of t equaling 4. 10 to the power of 0.03 to the power 10 to the power of 0.03t is equal to 4 divided by 10 to the power of 0.5. So if we calculate what this is, we get 10 to the power of 0.03t equals 1.26, etc. We now need to find the value of t. And so .03t is equal to log base 10 of 1.26, etc. So we have log base 10 of 4 over 10 to the power of 0.5. So 0.03t is equal to 0.102. And so therefore t is equal to 0.102, etc. divided by 0.03, which is 3.401, etc. And so therefore for the number of weeks it will take, we round this up, we have 4 weeks. It will take for the mass of algae to reach 4 kilograms. Now for part D, we have to state one reason why this may not be a realistic model in the long term. Well, the algae does not have unlimited space, food or light in which to grow, so it's unlikely to multiply at the same rate. Question number 6 for part A. We have to find the first 4 terms in ascending powers of x of the binomial expansion of 3 subtract 2x over 9, all raised to the power of 8, giving each term in simplest form. Here is how we calculate a binomial expansion for n belonging to a set of natural numbers. When we expand a plus b to the n, we have the result shown here. And so when we come to use the binomial expansion for 3 subtract 2x over 9 to the power of 8, we have 8 choose 0 multiplied by 3 to the power of 8 multiplied by 2x, or the negative 2x over 9 to the power of 0. And then we have 8 choose 1 multiplied by 3 raised to the power of 7 multiplied by negative 2x over 9 to the power of 1. Then for our next term, we have 8 choose 2 multiplied by 3 raised to the power of 6 multiplied by negative 2x over 9 to the power of 2. And then we have 8 choose 3 multiplied by 3 to the power of 5 multiplied by negative 2x over 9 to the power of 3. And then we've got higher order terms as well. So now let's calculate this. We have 8 choose 0 multiplied by 3 to the power of 8 multiplied by negative 2 over 9 to the power of 0. So for our first term, we have 6,561. For our next term, we have 8 choose 1 multiplied by 3 to the power of 7 multiplied by negative 2 over 9 to the power of 1. So we have negative 3,888 x. And then for the next term, we have 8 choose 2 multiplied by 3 to the power of 6 multiplied by negative 2/9 to the power of 2. So we add on positive 1008 x squared, and then we have 8 choose 3 multiplied by 3 to the power of 5 multiplied by negative 2/9 to the power of 3. So we have negative 488 over 3 x cubed plus higher order terms. Now for part B, f of x is equal to x minus 1 over 2x multiplied by 3 minus 2x over 9 to the 8. We have to find the coefficient of x squared in the series expansion of f of x, giving the answer as a simplified fraction. Well, for part B, we have f of x, which is x minus 1 over 2x multiplied by 3 subtract 2x over 9 to the power of 8. Now, the x minus 1 over 2x, we can rewrite this as x over 2x subtract 1 over 2x. And this is being multiplied by 3 minus 2x over 9 to the power of 8. Now, x over 2x, that's the same as 1/2. And then I'm subtracting from this 1 over 2x. And then this result is being multiplied by 3 minus 2x over 9 to the power of 8. And we know from part A, the first 4 terms of this result, we got 6,561, subtract 3,888x plus 1,008 x squared, subtract 488 x cubed over 3, plus higher order terms. Now what we need to do is find the coefficient of x squared. And so for us to find the coefficient of x squared, well, I have this 1/2 multiplied by the 1008 x squared. That gives an x squared term. So we have 1/2 multiplied by 1008 as a coefficient of x squared. And we would also have the negative 1 over 2x being multiplied by the negative 488 x cubed over 3, because here we've got the x cubed over the x, which gives an x squared. So we add on to this negative 1/2 multiplied by negative 488 over 3. And so if we work out what the coefficient of x squared is, we have 1/2 multiplied by 1008 plus 1/2 multiplied by 488 over 3. The negative and the negative here being multiplied by each other give the positive. And so the coefficient of x squared then is 1756 over 3. Question number 7, for part A, we have to factorize completely 9x minus x cubed. So for part A, we have 9x subtract x cubed. We can factorize out an x from both terms. So we have x multiplied by 9 subtract x squared. Now inside the bracket, hopefully you will notice we have a difference of 2 squares. And we can factorize that as 3 plus x multiplied by 3 minus x. So when we come to factorize 9x subtract x cubed, we end up with x multiplied by 3 plus x multiplied by 3 minus x. Now for part B, the curve C has equation y equals 9x minus x cubed. We have to sketch C showing the coordinates of the points at which the curve cuts the x-axis. So first of all, for part B, we know that y is equal to 9x minus x cubed. And when x is equal to 0, y is equal to 9 multiplied by 0, subtract 0 cubed. It turns out here we get 0. And when y equals 0, we can find out where it crosses the x-axis. So I've got 0 equals 9x multiplied by x cubed. So I've got 0 equals x multiplied by 3 plus x multiplied by 3 minus x. And so what we will be left with is x equals negative 3, 0, or 3. And so it crosses the x-axis at negative 3, 0, and 3. And because we've got a negative cubic, for our shape, we would have something looking like this, a negative cubic. So we have something looking like this for our graph. And it crosses the x-axis at the point 3, 0, the origin, and also the point 3, 0. Here is the graph of y equals 9x subtract x cubed. For part C of the question, the line L has equation y equals k, where k is a constant, and given that C and L intersect at 3 points, for part C we have to find the range of values for k, writing your answer in set notation. Now, if it intersects at 3 distinct points, then it intersects here, here, and here. But also, anywhere above here and below here is where y equals k would intersect C at 3 distinct points. So in between these values, hopefully you can see, is where I would have the range of values for k. And so here and here we have stationary points to the curve. In other words, here we have dy over dx equaling 0, and here we have dy over dx equaling 0. And so in between these values is where y equals k would intersect the curve C at 3 distinct points. So what we need to do before anything else is actually find out what dy over dx is, to find out the coordinates of the stationary point. And so if we work out what dy over dx is, differentiating 9x, we end up with 9. Differentiating x cubed, we end up with 3x squared. So dy over dx is equal to 9 subtract 3x squared. And because we have stationary points, we would have 9 subtract 3x squared equaling 0. So x squared is equal to 3, in which case we can see x is equal to plus minus square root of 3. So now that we know what the x coordinates of the stationary points are, we can find the corresponding y coordinates by substituting back into y equals 9x subtract x cubed. And so when x is equal to positive root 3, y equals 9 multiplied by root 3 subtract root 3 cubed. So it turns out we end up with 6 root 3. And when x equals negative root 3, y equals 9 multiplied by negative root 3 subtract negative root 3 cubed, which is negative 6 root 3. And so if we were to add those coordinates on, we have here negative root 3, negative 6 root 3, and here we have root 3, 6 root 3 as our coordinates of the stationary points. And so in between these values is where we would have the line y equals k intersecting the curve at exactly 3 points. And so in between these y values is the range of values of k we can have. And in set notation, we have k belonging to a set of real numbers. We've got negative 6 root 3 being less than k, being less than 6 root 3. Question number 8. The air pressure p kilograms per centimetre squared inside a car tyre t minutes from the instant when the tyre developed a puncture is given by the equation p equals k plus 1.4 e to the negative 0.5 t, where t is a real number greater or equal to 0 and k is a constant. Given that the initial air pressure inside the tyre was 2.2 kilograms per centimetre squared, we have to state the value of k. Well, because it says initial, that suggests to us t equals 0. And so for part A, when t equals 0, p equals 2.2. So we have 2.2 equals k plus 1.4 e to the power of 0. So we have 2.2 equals k plus 1.4, and so therefore we can conclude k is equal to 0.8, and therefore p is equal to 0.8, which is our value for k, plus 1.4 e to the power of negative 0.5 to the power of t. For part B, from the instant when the tyre developed the puncture, we have to find the time taken for the air pressure to fall to 1 kilogram per centimetre squared, give your answer in minutes to 1 decimal place. So, for part B, we are finding the corresponding value of t when p is equal to 1. So we have 1 equals 0.8 plus 1.4 e to the negative 0.5 t. So 1.4 e to the negative 0.5 t equals 0.2 e to the power of negative 0.5 t is equal to 0.2 divided by 1.4, which is 1/7. And so negative 0.5 t is equal to the natural log of 1/7. So t equals negative 2 times the natural log of 1/7. So working that out, we end up with a value of t of 3.9 minutes to 1 decimal place. And now for part C of the question, we have to find the rate at which the air pressure in the tyre is decreasing exactly 2 minutes from the instant when the tyre developed the puncture. Give your answer in kilograms per centimetre squared per minute to 3 significant figures. Well, because we are considering the rate of decrease, that suggests to us we first of all need to work out dp over dt. And so working out dp over dt, we have minus 0.7 e to the minus 0.5 t. And when t is equal to 2, dp over dt is equal to minus 0.7 e to the power of minus 0.5 multiplied by 2. So let's work out what this is. We get negative 0.2575, etc. And we can therefore conclude from this then, it's decreasing at a rate of 0.258 kilograms per centimetre squared, given to 3 significant figures. Question number 9 for part A. Given that p equals log base 3 of x, where x is greater than 0, we have to find in simplest form, in terms of p, for the first part, log base 3 of x over 9. Well, for the first part, we have log base 3 of x over 9, and that's equivalent to log base 3 of x subtract log base 3 of 9. That's using the subtraction law of logs. Now, log base 3 of x, we know that's equal to p. So we have p, and then log base 3 of 9, that's 2. So we have p minus 2 for log base 3 of x over 9. And then we have, for the next part, log base 3 of the square root of x. And what this is equivalent to is log base 3 of x to the power of 1/2. And if we use the power law of logs, it turns out this is the same as 1/2 times log base 3 of x, and log base 3 of x is p. So we end up with 1/2 p. Now for part b, hence or otherwise solve, 2 times log base 3 of x over 9 plus 3 times log base 3 of square root x equals -11, giving an answer as a simplified fraction. So for part b of the question, we have 2 times by log base 3 of x over 9 plus 3 times by log base 3 of the square root of x, and that's equal to -11. Now the result here we worked out previously as p subtract 2, so I've got 2 multiplied by p subtract 2 plus 3 multiplied by log base 3 of root x, which we found previously as 1/2 p, and this is equal to -11. So expanding, we have 2p minus 4 plus 3 over 2p equals -11, and if I multiply through by the 2, we have 4p subtract 8 plus 3p equals -22. 7p is equal to -14. That means p is equal to -2. Now we weren't after the value of p, we were after the value of x. So now I have to use the fact that p equals log base 3 of x to find out what x is. So we have log base 3 of x equals -2. So x is equal to 3 raised to the power of -2, and therefore as a fraction it turns out x is equal to 1/9. Question number 10. Figure 2 shows a sketch of part of the curve C with equation y equals 1/3 x squared subtract 2 times the square root of x plus 3, where x is greater or equal to 0. The point P lies on C and has an x coordinate of 4. So we've got an x coordinate of 4. And the line L is the tangent to C at the point P. And for part A we have to show that L has equation 13x minus 6y minus 26 equals 0. Well, if L is a tangent to C at the point P, that suggests to us at some point we need to differentiate. Now, before we differentiate, let's rewrite the equation for y as y equals 1/3 x squared subtract 2x to the power of 1/2 plus 3. And the reason I am doing this is because it will be easier to differentiate. Dy over dx then, if I differentiate, we end up with 2 over 3 x subtract x to the power of negative 1/2. And what we can do now is find out what the corresponding y coordinate of P is, and also the gradient of the tangent at the point P. We can do this by substituting x equals 4 into both y and dy over dx. So, when x equals 4, y equals 1/3 times by 4 squared, subtract 2 times by 4 to the power of 1/2 plus 3. And it turns out y is equal to 13 over 3. And so therefore, the coordinates of P, we have 4 and 13 over 3. So let's add on the y coordinate of 13 over 3. We can also find out what the gradient of the tangent is by substituting x equals 4 into dy over dx. So we have 2/3 times by 4, subtract 4 to the power of negative 1/2. And if we work out what this is, it turns out we get 13 over 6. And this 13 over 6 would represent the gradient of the tangent. And so therefore, at the point P with coordinates 4 and 13 over 3, the equation of the line will be y subtract 13 over 3 equals 13 over 6 multiplied by x minus 4. And if I multiply through by 6, we've got 6y subtract 2 times by 13 equals 13 multiplied by x minus 4. So I have 6y subtract 26 equals 13x minus 52. And if we take everything over to one side, we can therefore conclude the equation of the line L, that's 13x minus 6y minus 26 equals 0. For part B of the question, the region R, shown shaded in figure 2, is bounded by the y-axis, the curve C, and the line L and the x-axis, and we have to find the exact area of R. Now, what we know so far regarding the line L, it has equation 13x subtract 6y subtract 26 equals 0. And we've also got the curve C with equation y equals 1/3 x squared subtract 2 times the square root of x plus 3. And so what we can do to begin with is find out where L crosses the x-axis, and we can do that by setting y equal to 0. And so we have 13x subtract 0 subtract 26 equals 0. 13x is equal to 26. X is therefore equal to 2. So that means the point over here has coordinates 2, 0. And what we can now do is find the area under the curve between 0 and 4. And from that we can find the area of triangle over here. So let's begin by finding the area under the curve. We would have to integrate between 0 and 4 the curve C, which is 1/3 x squared, subtract 2x to the 1/2 plus 3 dx. So if we integrate, well, integrating 1/3 x squared, we end up with 1/9 x cubed. Integrating negative 2x to the half, we end up with negative 4/3 x to the 3/2 plus 3x. And I'm integrating between 0 and 4. So if we work this out, we have 1/9 multiplied by 4 to the power of 3, subtract 4/3 multiplied by 4 to the power of 3/2 plus 3 multiplied by 4. And for my lower limit, we have 0 minus 0 plus 0. And so what we end up with for the area under the curve is 76/9. Now we can find out the area of this triangle. For the area of the triangle, we've got 1/2 times by the base. Now the base here, we are going from 2 to 4, so the base here is the difference between that, which is 2, and the height, we are going from 0 to 13/3. And so if we work out the area of the triangle, it turns out we get 13/3. And so therefore, the area of R is equal to the area under the curve, 76/9. So this is the area under the curve, which is 76/9. Subtract 13/3, and if we work this out, the area of R then is equal to 37/9 units squared. Question number 11. Figure 3 shows the circle C with equation x squared plus y squared minus 10x minus 8y plus 32 equals 0, and the line with equation 2y plus x plus 6 equals 0. What we have to do for part A is find the coordinates of the center of the circle C and the radius of the circle C. So, for part A, we have x squared plus y squared, subtract 10x, subtract 8y, plus 32 equals 0. And for us to find the center and the radius, we need to complete the square. And if I complete the square, we have x minus 5, so that's half the coefficient of x, and then squared. And then we subtract the square of 5. And then, in terms of the y's, we have y minus 4 squared, and then I subtract the square of 4. And then I add on 32, and the result is equal to 0. So we have x minus 5 squared plus y minus 4 squared, and then we have negative 25 subtract 16 plus 32, which is negative 9. And if I take that over to the right hand side, we have x minus 5 all squared plus y minus 4 all squared equals 9. And so we have x plus 5 all squared plus y minus 4 all squared equals 3 squared, from which we can conclude the center has coordinates 5, 4, and the radius is equal to 3. So if I go back to my diagram, we have the center 5, 4 and the radius of 3. Now for part B of the question, we have to find the shortest distance between C and L. So what we want in this question is the shortest distance, which will be this distance over here, and we'll call this D for the shortest distance. And for us to find out that shortest distance, well, what we can see is this line and this line L will be perpendicular. That's how we get the shortest distance. Anything such as the line here won't give the shortest distance. We need a line which is perpendicular to L to C, which will give us the shortest distance. Now, if we have the line L over here, well, we'll call this line L1. What we can do is find out the equation of this line L2, say, and find out where this coordinate is, and from that we can somehow find out the distance from here to the center, and then subtracting 3 will give us the shortest distance, D. So we need to find out the equation of L2. Now, we know that L1 and L2 are perpendicular to each other. So, for part B, if I consider the line L1, then we have 2y plus x plus 6 equals 0. 2y is equal to negative x subtract 6. And so if I divide by 2, y is equal to negative 1/2 x subtract 3. And so what we can see here then, the gradient of L1 is negative 1/2. And because L2 is perpendicular to L1, we can say that the gradient of L2 is the negative reciprocal of negative a half, which is 2. So the gradient of L2 is 2. And we know that L2 passes through the centre with coordinates 5, 4. And so if I consider the point 5, 4, the equation of the line L2, we have y minus 4 equals 2 multiplied by x minus 5. So the line L2, we have y equals 2x subtract 6. So that is what L2 is. The line L2 has equation 2 y equals 2x minus 6, and the line L1 we have just worked out to be y equals negative 1 half x negative 3. So now we can find out where L1 and L2 intersect by setting this equation here for L1 equal to this equation L2. And so, if I set those equal to each other, we have the line L1, which is negative 1 half x, subtract 3, and that's equal to 2x minus 6. So if I multiply through by 2, we have negative x subtract 6 equals 4x subtract 12. Rearranging, we see that 5x is equal to 6, in which case we see x is equal to 6 over 5. And so we can find out the corresponding y coordinate by substituting into either equation. So when x is equal to 6 over 5, y equals negative 1 half multiplied by 6 over 5 subtract 3, which is equal to negative 18 over 5. So if I add on the coordinates here, we've got 6 over 5, and we also have negative 18 over 5 as our coordinates where L1 and L2 intersect. So now that we know where they intersect, we can now find out the distance from L1 to the center of C. So the distance from L1 to the center of C, that's equal to, well, we have 5 subtract 6 over 5 squared plus 4 subtract negative 18 over 5 squared, and then square rooted. So if we work this out, we've got the square root of 6 subtract 6 over 5 squared plus 4 subtract negative 18 over 5 squared rather here we get an answer then of 19 root 5 over 5. So that's the distance from L1 to M, the centre. And so what we need to do now, to find out this distance t, I need to subtract off this radius of 3. So, to find out the required distance, that's equal to 19 root 5 divided by 5, subtract the radius of 3, so therefore the required distance in exact form, we have 19 times the square root of 5, subtract 15 over 5. This is the exact distance from L to C. So we have 19 root 5 minus 15 over 5. Question number 12. A company makes drinks containers out of metal. The containers are modelled as closed cylinders with base radius r centimeters and height h centimeters, and the capacity of each container is 355 centimeters cubed. The metal used for the circular base and the curved side costs 0.04 pence per centimeter squared. For the circular top costs 0.09 pence per centimeter squared. Both metals used are of negligible thickness. For part A, we have to show that the total cost, C pence, of the metal for one container is given by C equals 0.13 pi r squared plus 28.4 over r. Now, how would we find the volume of a cylindrical container? Well, the volume will be given by pi multiplied by radius squared multiplied by h. And I know that this is equal to 355. Now, if I take a look at what C is, C doesn't contain anything involving h. So at this point, let's rearrange for h. And if I do that, I end up with 355 over pi r squared. Now, we've got the base, which costs 0.04 pence per centimeter squared, and we've also got the side, which costs 0.04 pence per centimeter squared. So the cost of the base, we have pi r squared, we've got a circular base, but then we need to multiply this by the cost, which is 0.04. So that's the cost of the base. For the cost of the side, well, if I think about my cylinder, for the side bit, we can open that up as a rectangle. The length of it will be the diameter times by the pi to give the circumference. So this length is the circumference of the circle, and that's given by 2 pi r, and then we've got the h over here. So the area will be given by 2 pi rh. So for the cost of the side, we've got 2 pi rh, but then I multiply this by the cost, which is 0.04 0.04. And because I know that h is equal to 355 over pi r squared, what we end up with then is 0.04 multiplied by 2 pi r multiplied by h, which is 355 over pi r squared. So let's work this out. I've got 0.04 times 2 times 355. That gives the 28.4. And then I've got the pi and the 1 over pi simplifying to 1. And then I've got r divided by r squared, which is 1 over r. So the cost of the side is 28.4 over r. And the cost of the top is 0.09 pence per centimetre squared. We've got a circular top. So the cost of the top, I've got 0.09 multiplied by pi r squared. And so therefore, the total cost, I've got the cost of the base, 0.04 pi r squared, plus the cost of the side, 28.4 divided by r, plus the cost of the top, 0.09 pi r squared. And so the total cost C, that's equal to 0.13 pi r squared plus 28.4 over r. Now for part B, we have to use calculus to find the value of r for which C is a minimum, giving an answer to 3 significant figures. Well, when we use calculus, that suggests to us we need to differentiate C. And so therefore, for part B, if we differentiate C, dc over dr, that's equal to, well, differentiating 0.13 pi r squared, remembering pi is just a number, we end up with 0.26 pi r. And if I differentiate 28.4 over r, I end up with minus 28.4 over r squared. So that's what dc over dr is. And now, because I am finding the value of r for which C is a minimum, that suggests to me I need to set dc over dr equal to 0. And if I do that, I've got 0.26 pi multiplied by r, subtract 28.4 over r equals 0. So if I multiply through by r and then divide by 0.26 pi and take the 28.4 to the right hand side, we end up with r cubed equaling 28.4 divided by 0.26 pi. And so if I find out what r is, we have 28.4 divided by 0.26 pi being cube rooted, which is 3.26 That's given to 3 significant figures, and the units are centimetres. Now let's store this into A, just in case we need it later on. Now for part C, using d squared c over dr squared, we have to prove that the cost is minimised for the value of r found in part B. So I know what dc over dr is, now I have to differentiate this to find out what d squared c over dr squared is. D squared c over dr squared, that's equal to 0.26 pi plus 56.8 divided by r cubed. And if you want, you can rewrite this in indice form and then differentiate. And so now that I know what d squared c over dr squared is, let's see what happens when r equals 3.2, etc. In this case, d squared c over dr squared is equal to 0.26 pi plus 56.8 divided by 3.2, etc. cubed. So we've got 0.26 pi plus 56.8 over 3.2, etc. cubed. So let's just double check this. We get a value which is definitely greater than 0. And so, because the second derivative is greater than 0, we can therefore conclude that the cost is minimized. And now for part D, hence find the minimum value of c, giving an answer to the nearest integer. So, for part D, with our value of r equals 3.2, etc., we can substitute this in to find out what c is. So I've got my value of r, and I can substitute this into c, which we worked out previously, to find out what the minimum cost is. And the reason we substitute r equals 3.2, etc., this gives us the minimum cost. So the minimum value of c is equal to 0.13 pi multiplied by 3.2, etc. squared plus 28.4 divided by 3.2, etc. cubed. So if we work this out, I've got 0.13 pi multiplied by this squared, rather here, this is not cubed, plus 28.4 over 3.2, etc. And it turns out we get 13.05, etc. And so the minimum cost is 13p. Question number 13. For part A, we have to show that 1 over cos theta plus tan theta is equivalent to cos theta over 1 minus sin theta, where theta doesn't equal 2n plus 1 lots of 90 degrees, where n belongs to a set of integers. So for part A of the question, we begin with 1 over, well, let's be explicit, on the left hand side, we've got 1 over cos theta plus tan theta and we know that tan theta is the same as sin theta over cos theta, so I've got 1 over cos theta plus sin theta over cos theta, and because we've got a cos theta as a common denominator, that means we can combine the fractions, leaving us with 1 plus sin theta divided by cos theta. Now, if I pay attention to what I have over on the right hand side, well, we have on the right hand side cos theta divided by 1 minus sin theta, and if we think about how we could end up from here to here, well, because I've got a 1 minus sin theta on the bottom, what we really want on the bottom is a 1 minus sin theta. So if over here we have a 1 minus sin theta on the bottom, that means on the top I also need a 1 minus sin theta to maintain equivalence. And really what I want is for the cos theta to cancel with something on the top, leaving me with just the 1 minus sin theta on the bottom. Well, if I expand along the top, 1 plus sin theta multiplied by 1 minus sin theta, that is the same as 1 minus sin theta squared. And on the bottom, I've got cos theta multiplied by 1 minus sin theta. And at this point, we can recognize that 1 minus sin squared is cos squared. So we have cos squared theta divided by cos theta multiplied by 1 minus sin theta. And so at this point, hopefully we can recognize that cos squared divided by cos is just cos. So we are left with cos theta divided by 1 minus sin theta. And that's exactly what I wanted to show for part A. And so, as the left hand side is therefore equivalent to the right hand side, we have shown the identity to be true. Now for part B, given that cos of 2x doesn't equal 0, we have to solve for x being in between 0 and 90 degrees. The equation 1 over cos 2x plus tan 2x equals 3 cos 2x, giving an answer to 1 decimal place. Now here I've got a theta and here I've got a 2x. And so what we can do is replace the right hand side with cos 2x over 1 minus sin 2x. So for part B of the question, we've got the equation 1 over cos 2x plus tan 2x equals 3 times by cos 2x. And we are solving this in the domain 0 to 90 degrees. Now, first thing we need to do is change the domain. And if I change the domain, here I've got an x, I want a 2x. 0 multiplied by 2 is 0. 90 multiplied by 2 is 180. So I need to solve initially for values in between 0 and 180. Now, 1 over cos 2x plus tan 2x, using the result which we wanted to show, we can then say for our equation we have cos 2x over 1 minus sin 2x equals 3 cos 2x. In fact, let's move this over here. So we are solving this equation between 0 and 180. So if I multiply through by 1 minus sin 2x, that means we've got cos 2x equals 3 cos 2x multiplied by 1 minus sin 2x. And if we take everything over to one side, I've got cos 2x subtract 3 cos 2x multiplied by 1 minus sin 2x equals 0. And if I factorize out a cos 2x, then I've got 1 minus 3 multiplied by 1 minus sin 2x equals 0. And if we expand, well, first of all I've got cos 2x, and then here I've got 1 subtract 3, so that's negative 2, and then I've got negative 3 times by negative sin 2x, so that will be 3 sin 2x subtract 2, and this is equal to 0. And so what we have then is cos 2x, which doesn't equal 0, we were told that in the question, or we've got 3 sin 2x subtract 2 equals 0. And we need to solve this in between 0 and 180. So, from here, we can see then that sin x is equal to 2/3, and therefore 2x is equal to, well here, because I've changed the domain, if I do the inverse sine of 2 over 3, 2x is equal to 41.81, etc. And to find the next value, I need to do 180 minus this, which is 138.18. etc. So if I divide these values by 2 to find out what x is to one decimal place, I've got a solution of 69.1 degrees, and I also have 20.9 degrees, and these solutions are given to one decimal place. Question number 14, a student states, if x squared is greater than 9, then x must be greater than 3. You have to determine whether or not this statement is true, giving a reason for your answer. Well, for the first part, the claim is, if x squared is greater than 9, then x must be greater than 3. We have to test this. Well, we can just come up with a counterexample. For example, if we have x equaling -4, then -4 squared, which is 16, that's greater than 9. But -4 is less than the 3. This bit is quite crucial. It's less than the 3. We're saying if x squared is greater than 9, then x is greater than 3. We've just found an example where x would be less than 3 in that case. And so the statement is false. Now, another way to think about it is to think, well, if I have x squared being greater than 9, this will imply x squared minus 9 is greater than 0, which implies x plus 3 multiplied by x minus 3 is greater than 0. And if I think about a sketch of the graph, where it's greater than 0 is here and here. And so from here we can see that x is greater than 3, or we have x which is less than -3, which are solutions. So either way, from solving the inequality algebraically, we can see either way the statement is false. So we see then the statement is false. Now for the next part, we have to prove that for all positive integers n cubed plus 3n squared plus 2n is divisible by 6. Well, for the next part, we've got n cubed plus 3n squared plus 2n. This is equivalent to n multiplied by n squared plus 3n plus 2. So I have n multiplied by n plus 1 multiplied by n plus 2 when I come to factorize fully. And what do we notice about these? Well, here what we have is the product of 3 consecutive integers. N multiplied by n plus 1 multiplied by n plus 2 is the product of 3 consecutive integers. Now, what we'll do is we'll come up with some examples of these. Well, examples of 3 consecutive integers, I could have 7, 8, 9. I could have, well, we'll choose small numbers for now. I could have 16, 17, and 18. I could have 23, 24, and 25. What we see here are examples of consecutive integers, and well, let's just write that down. Here then we've got examples of consecutive integers, and what we want to show is that the product of these numbers in general will always be divisible by 6. Well, what do you notice? Hopefully you notice is one of the numbers is divisible by 3. So for example, well, let's just highlight this. One of the numbers is divisible by 3. So for example, the 24 is divisible by 3. The 18 is divisible by 3. Here the 9 is divisible by 3. And hopefully what you also notice is at least one of them will be divisible by 2. So in this case, the 8 is divisible by 2. In this case, the 16 and the 18 are both divisible by 2. And in this case, the 24 is divisible by 2. So at least one of the numbers will be divisible by 2. So if one of the numbers is divisible by 3 and the other one is divisible by 2, the product contains both 2 and the 3 as prime factors, and because the product has 2 and 3 as prime factors, that means the product of 3 consecutive integers is divisible by 6. And what this is over here is n multiplied by n plus 1 multiplied by n plus 2. And so, therefore, n cubed plus 3n squared plus 2n, which is the same thing as n times n plus 1 times n plus 2, this result is divisible by 6, and that's exactly what we wanted to show.